Okay, welcome back. Continuing in Module 3, we're still Topic 2, or Lesson 4, Activity 1. We're on page 441. This first page gives kind of a lot of information. Identifying solutions. It says equations come in many forms. Because expressions are either numeric or algebraic, equations can be made of just numbers, numeric, or both numbers and variables, which is algebraic. Equations are statements. They may always be true, never be true, or be true only for one or more of the variables. So examples of always true, a numerical statement that's always true, 6 equals 10 minus 4, and an algebraic is x equals x. Never true, 10 equals 20 as a numeric, x equals x plus 2. You can never have a value for x that will equal whatever your value of x is when you add 2 to the other side. Isn't going to work. True for certain variables, x equals 5. So in this one, x is just 5. It's nothing else. X plus 2 equals 12. So here the value of x in this one would be x equals 10. So these are true for only certain values of the variable. When you determine that an equation is never true, you can make it a true statement by using the not equal to symbol, which is the equal to line. I'm going to try to zoom in on that with a line through it. Okay. So, for example, you should write 10 equals 20 actually as 10 is not equal to 20. So, it's an equal sign with a line slash through it. Use the given expressions to write the type of equation described. And then it says explain why the equation has no solution. So write an equation using two expressions. Write an equation using two expressions that has no possible solution. So from these. So no solution at all. So how about x plus 3 equals x? So no matter the value of x, the left side of the equation will always be 3 greater than the right. And it says write an expression that is true no matter what number you substitute for the variable. So I see these 3 plus x equals x plus 3. So no matter what I put in for x, I'm going to end up with the same value on the left as I do on the right. So any value substituted for x will make a true statement because I don't like this pencil. Each side will have the same value. Pause if you need to write it. I'm going to flip and keep going. Analyze each equation and identify whether it has one solution, no solutions, or an infinite number of solutions. Then solve the inequality. So for A, 5/8 equals x plus 1/2. So just from looking at it, I think that we are going to have just one solution for it. I think that there's only going to be one thing I can put in for x that'll give me 5/8 when added to the 1/2. So I'm going to guess one solution, and let's see if we can prove that. So it looks like I need to subtract 1/2, subtract 1/2. Now 5/8 minus 1/2. So 1/2 rewritten in eighths is going to be 4/8. So I'm actually doing 5/8 minus 4/8. I'm going to rewrite that as 4/8. Oh my goodness. I think I'm going to switch to a pen. 5/8 minus 4/8 is 1/8 equals x. So I'm correct. There is just one solution to that. Okay, letter B. X times 1 equals x. Well, anything times 1 is going to be equal to itself. So I think it's not going to matter. So I think there's going to be an infinite number of solutions. So infinite solutions. So if I divide this side by 1 and I divide by 1, I'm going to get x equals, anything divided by 1 is just the anything. So whenever x equals x, any value will make it true. So in here, any value for x multiplied by 1 will still equal x. Okay, letter C. 11 plus x equals 11. Again, immediately you probably are shouting at me right now that it's a 0. So I'm going to guess one solution. Let's check. So if I subtract 11, x equals 0. If I plug that back in, 11 plus 0 equals 11. That is in fact true. Is there anything else I can put in for x that when added to 11 will give me 11? Nope, just one solution. Okay, x divided by 10 equals 1/10. So if I need to isolate the variable, it's dividing here. So it's really 1/10 x equals 1/10. So if I multiply by 10 over 1 and I multiply by 10, this becomes 1x. So just x equals 1/10 times 10. So 1/10 of 10 is 1. So we're getting just x equals 1 number, so it's going to be one solution. Because 1 divided by 10, putting 1 in for the x equals 1/10. That is true. 1/10, that says 1/10, and so does that. Okay, x plus 5 equals x plus 4. Is there ever going to be a value that I can put in for x that'll get the same thing on the left and the right? There isn't, so there's no solution. So, like if I try to get x just on one side, so I have it equaling something, both of the x's end up canceling out, and I have 5 equals 4. Well, 5 does not equal 4, so there's no solution. X plus 0 equals x. So if I put a 1 in there, 1 plus 0 is 1. That would work. What about a 5? 5 plus 0 equals 5. So that works. Because essentially, x plus 0 is just like saying x equals x. So there is an infinite amount, infinite number of solutions. you can add 0 to any x value and still get x. Okay, x times 10 equals 30. So I don't think I'm going to be able to change the values. So if I did x times 1, that would be 10 equals 30. If I did x times 2, that would be 20 equals 30. So I don't think that's going to work. So if I divide by 10, I get x equals 3, which is just one solution. Only 3 makes it true. X plus 8 equals x. We've done ones like this before. It looks very similar to this, but this time instead of there being 2 of the 8s, there's 2 of the x's, but I can't have a value of x here and a value of x here and add 8 to that and end up with the same thing. So there's no solutions. The expression on the left will always be 8 higher than the right. Pause as you need to. X plus 3 and 5/10 equals 14 and 75/100. It seems like when I have just one x value and any operation with it, and then equaling a rational number on the other side, so a whole number or a decimal or a fraction on the other side, I seem to have just one solution. So if I subtract 3 and 5/10 from both sides, I get x equals, that'd be a 0 there. I get 11 and 25/100, so that's one solution. Only 11 and 25/100 makes the equation true. 0 times x equals 0. So if I put a 1 in for x, 0 times 1 is 0, so 0 equals 0. If I put a 5 in, 0 times 5 equals 0, 0 equals 0. If I did a million, 0 times a million equals 0, so 0 equals 0. So this one, there's going to be an infinite number of solutions. I'll spell that out, infinite number of solutions. You can have, well, let's say you can multiply any value of x by 0, and you will always get 0. Okay, then there's one more page for this one. Equations that have an infinite number of solutions are equations that are true no matter the value you assign to the variable. The structure of these equations often describe important properties of the numbers. Consider each property. So the 0 property of multiplication states that the product of any number and 0 is 0. We just did that one. The identity property of multiplication states that the product of any number and 1 is the number. We know that. So this one is like 0 times any number equals 0. This is the product of any number and 1. So x times 1 equals the number. And the identity property of addition states that the sum of any number and 0 is the number. So any number plus 0 equals the number. Analyze the equations you solved in question 2, which states the zero property of multiplication. So zero property of multiplication, so multiplying by 0, so that would be letter J, which was 0 times x equals 0. That was letter J. Which equation states the identity property of multiplication? So that's x times 1. So that one was, which one? Okay, so that one was up here in letter B. So that was B, x times 1 equals x. That's written horribly. Which equation states the identity property of addition? So that's going to be x plus 0. And that one was here at letter F. Okay, number 4, for each solution, write a different equation with that solution. So it just wants us to write an equation that we would get x equals 1/4. So, for example, let's see, we could say 4x equals 1. Because in that, to solve it, I would divide by 4 and divide by 4, so I would get x equals 1/4. So the answer could be 4x equals 1. X equals 6. So let's see, I could say maybe x plus 5 equals 11. So if I put a 6 in here, 6 plus 5 equals 11. So that one would work. That would give me a 6. We could have one that is like 30 divided by x equals 5. So 30 divided by what gives you 5? 6. And then last, x equals 1/10. So if we did, and they gave us one of these. I think I liked that one. Oh, maybe we could change it a little bit though. 10 times x equals 1. So if I divide both sides by 10, I get x equals 1/10. So 10x equals 1 would be a valid answer. Okay, and we will see you on the next video for activity 2.